Welcome to lecture 39. So, today we will discuss parameter passing. So, since most of the issues are pragmatic, though it is really and it is also tremendously complicated to give us semantics. So, what we will do is we will discuss most of the basic parameter passing mechanisms from a purely pragmatic viewpoint, and it is possible to give a semantics, but then that is a semantics of an afterthought, and it is not a predefined semantics in the sense that. So, as a result, especially for imperative languages, it becomes very messy and rather complicated and actually does not provide too much intuition, at least in my opinion. So, but what it can do of course is to accurately pin down exactly how it should be implemented, what are the considerations, but however we will look at it from a purely pragmatic point of view. It is most elegantly discussed only in a functional setting or in a lambda calculus setting with a toy language. So, as I said, most functional languages use call by value, which is that given an operator and an operand, you completely evaluate the operand before you actually perform the application. Right. Now, the whole question of and as I said, in the particular case of the applied lambda calculi, whether type in the case of typed applied lambda calculi, which is what most functional languages are, call by value and call by name give the same results, but call by value is likely to give you a faster convergence to the normal form. In the untyped case, call by name is always guaranteed to give you a normal form if it exists, but call by value might go off into an infinite computation. So, that is one important reason why you should introduce typing, so that then you are guaranteed that you will always get normal forms. Secondly, from a purely pragmatic viewpoint, you can use call by value, which is an easy implementation compared to a call by name implementation. Anyway, coming to procedural languages or imperative languages, the whole question of parameter passing is closely related to what might be called an attitudinal problem, right. So, essentially, given a function or a procedure call, the question is, and this in general could be an expression, this E, which is why I have put it in dark green, but very often it is just a single name of a variable or of an array component or a record field. So, very often it is just a name of some object, and in imperative languages, if you remember, objects could have, even simple variables actually have different interpretations. For example, depending on whether they occur on the left hand side of an assignment or on the right hand side of an assignment. I mean, assignment in some form or the other is the most important construct in an imperative language, right, and and a name has a different meaning depending upon whether it occurs on the left hand side or on the right hand side of an assignment. So, when it occurs on the left hand side, you are essentially referring to its location or its address, and a variable is really like a container, then a container which can contain a value, and if it occurs on the right hand side, you are really looking at not the location, but the value contained in a particular location. So, I made this distinction between L values and R values long ago, and essentially that confusion resides here. Okay. So, the attitude, or the interpretation that you can give an expression, if it is a simple arithmetic expression or some such thing, there is really nothing you can do. I mean, it is actually there is still confusion there too, but as we will see. But so, the attitude that you can take is, if the parameter E denotes an R value, then what you mean is that this E is really a value, and therefore, the value is what has to be passed as the actual parameter of this procedure call. Okay. And if you regard this expression as denoting a value, then essentially you will be using a call by value mechanism. On the other hand, you could regard this expression as an L value, okay, which means that it should be an expression for which there is a possibility of that confusion between an R value and an L value. I mean, if it is just some arithmetic expression of the form 2 plus 3, then clearly it has no L value. Okay. So, but where it could be a simple variable or an array component or a record field, in such cases what happens is that so then that expression is open to two different interpretations, either as the value of the value contained in a location or the location itself. Okay. So, then here what you are saying is, should I pass the location itself as the parameter? After all, that expression, if it contains, if it could be interpreted as an L value, then it is just the name of a certain object, right? And I am passing that, which object? Am I passing that object itself, or am I passing the value contained inside that object? Okay. So, if I am passing that object itself, then it is really an L value that I am looking at, and what you get if you take that attitude is what is known as a call by reference mechanism. And there is actually a third attitude. If it is some expression, then whether it might have if it is an expression, then it certainly has an R value, let us say. It may or may not have an L value, but then can I say that when I am calling this procedure, I am not passing either the L value or the R value, but I am passing the expression itself as a parameter. In large parts of mathematics, actually this confusion never arose, okay? And that is because whether you pass the expression itself or you pass the value of the expression as a parameter, you are always guaranteed the same results in mathematics, okay? And that really has to do with the fact that whether you do a call by value reduction of a lambda term or a leftmost outermost reduction of a lambda term, in either case the results, if they are not an infinite computation, will yield the same normal form, and that is a call by value, that is the call by name implementation. I can look upon the parameter itself as just a plain piece of text, which is what I am interested in passing. I am not interested in it passing its value, I am not interested in passing its location, I am really passing just a plain piece of text, and this is really what happens in a beta reduction in the lambda calculus. And because the lambda calculus is such that, especially the type lambda calculus, regardless of whether you pass it as a value or you pass it as a piece of text, you get the same normal forms. Therefore, in mathematics there is no question of an L value. Therefore, so the only confusion there could have been is whether you are passing, when you do a function application, whether you are passing a value or an expression regarded as a piece of text, okay. But that confusion in the type lambda calculi, since it is guaranteed that you will always get normal forms and you will get the same normal form always, it did not matter, a call by value or a call by name implementation. However, in any programming language in which locations are also closely interwoven into the language, what happens is that this call by value and call by name can produce different results. Yeah. Okay. So the call by name, or what in the lambda calculus would be the leftmost outermost beta reduction rule. That means you scan a lambda term, the moment you find a lambda application, take the take the operator and the operand, do not reduce the operand, apply the left, starting from the left, the outermost application has to be done first. Then in that case the operand itself could be something that is capable of being reduced, but you do not reduce it. And when you do the beta reduction, what you are doing is substituting the entire text of the operand in place of a free variable in the body of a lambda abstraction, right. That is a call by name method of parsing. Yeah. Okay, so let's look at, I mean, these three are the most important for these reasons actually. Though call by name is really not being used too much, but you cannot really justify a lot of things, especially in functional languages, without actually proving, for example, that they will give you the same semantics as call by name and so on. So, however, there are so the call by value is something that is implemented in Pascal, C and most languages, most imperative languages. Call by name, the only imperative language in which I know it was implemented was Algol 60 and certain derivatives of Algol 60, which, well, like the Stanford artificial intelligence language SAIL, I think used call by name, right, but it is a very dicey kind of thing to implement. So, it is quite unpopular. Call by reference, of course, is there in Pascal and Fortran, and then there is also something called call by value result, and I say ADA question mark because it is not clear what ADA wants you to implement. Okay, it is not absolutely clear. We will see the reason for that. Okay, so let us look at this. So, when since call by values, if you remember the activation records and stack and so on, there was a place for parameters. So, I will not go back to that, just keep that in mind. So, in a call by value implementation, what you do is you evaluate the actual parameter to obtain a value. So, the actual parameter could be an expression including, let us say, an arithmetic expression containing just constants, if you like, whatever, but you actually do all the possible reductions that are possible till you get a value, right. And having done that, there is a formal parameter, right. Let's look at the general structure of procedures. You will have, let us say, a procedure text which has some formal parameters. Okay, let's call it x. Let's just assume one parameter, and then you might have a call to this procedure. The procedure has a name, let's say p, and you might have a call to this procedure. This procedure could also be a Pascal function, and what I mean is there is no fundamental difference between functions in procedures in Pascal or in Fortran, because all it means is having an extra local variable to store the result, otherwise they are both absolutely the same, right. So, we will just look at them as procedures, and there is an actual parameter, okay, and of course, you have to draw the formal to actual correspondence, and the whole question of interpretation now reduces to, in this call, should x denote the value, the R value of A, should x denote the L value of A, or should x be the name for this piece of text, just a name for this piece of text, right. That is really all that those are the three mechanisms that we are really interested in looking at, right. So, so then what do you do in a call by value implementation? You evaluate the actual parameter down to an R value, okay, and assign the formal parameter this value. That means you are explicitly you are performing an implicit assignment operation, okay, where the formal parameter is initialized to this value, right, and then you execute the procedure or function with this initialization of the formal parameters, right. So, now because of this particular way of going about things, supposing the actual parameter were an expression that could be an L value, either the actual parameter is a simple variable, an array component, or let us say a record field. Then what happens is this process does not, for example, change the value of values of the so within the procedure or function, if you change the value of the formal parameter, that is not reflected in the value of the actual parameter. Okay. So, this call by value implementation, if you take a broad pragmatic view, is really for doing things like I have got a value a and I want to find sin a or cos a, elementary mathematical functions where you are not really interested in producing side effects. Of course, what happens with most of our programs is that within the function there are side effects due to various reasons, many and very often the reasons lie in Pascal or the appropriate language. For example, Pascal has a restriction that a Pascal function can return only an scalar data type value. Supposing I have a function which actually has to return two different values, what do I do? So, I might do some silly thing like making one of the values global, returning one value and producing a side effect within the function. That is one possible way of doing it. So, we do such things, but whatever are the changes in the values of the formal parameter in the execution of the procedure will not be reflected back unless you actually use that actual parameter also, as you modify that actual parameter also in the procedure or function. So, changes in the formal will not be reflected back in the actual in general, but there are specific instances where it could, right. So now, what kinds of variations can you have? For example, you could have so your actual parameter could be, as I said, so it could be the value of a base type, yeah. So, which means that there will be no side effects possible. I am talking of these side effects. Whenever I talk of no side effects possible, I mean side effects through modification of the formal parameter and not side effects created by explicit assignments to global variables within the function or the procedure, right. However, the R value of the actual parameter could be a location. After all, a location is also locations, the addresses are also R values. So, it could be a location, in which case what happens is that you are essentially dealing with pointers, and then all assignments to formal parameters are immediately reflected in the actual. In fact, if I were to write various list based programs in Pascal, for example, I want to take all these scheme functions, elementary scheme functions, and program them in Pascal. So, what would I do? Well, I would define a function called cons, which takes, let us say, a value and a pointer to a list, and I would actually cons it and do things. So, and that pointer to the list could just be a call by value parameter. But since it is a pointer and I am going to go through this process of first creating a new location and then modifying the pointer and so on and so forth, I will actually get side effects. The end result that I get would actually be a new list with that new element const to it. So, under cases where the R value is actually an address, you could actually so what it means is that there is a global, there is a heap based data structure which you are modifying somewhere, you are not actually modifying the value of the location in the formal, okay, but you are modifying some large structure that is pointed to by this R value, and once you have modified that you have essentially got you have essentially changed your global environment. So, on your return from the procedure you have got a modified global environment, right. So, for example, lopping off the head of a list, I mean I could just pass the list as a pointer, okay, lop off the head by deallocating the head, putting the pointers in some particular way and then just get back. Ostensibly there are no side effects because of a call by value implementation, but the new list that I get is really the tail of the original list, and in fact this is what is used mostly in C to produce side effects. C uses only a single parameter passing mechanism, and that is call by value, and the way it uses call by value, even though it for normal variables call by value produces no side effects, the way it produces call by value is that it uses value parameters through explicit referencing and dereferencing operations. So, you can actually pass a value which is a pointer to something, okay, dereference that pointer, change the value through an explicit call by value mechanism and get back, and you would have produced side effects though the actual parameter would not have changed its value, right. It would still be a pointer to the same location, but you change the contents of that location and so you produced a side effect. Yes, so that is how C, for example, does not allow for any other parameter passing mechanism, it allows only for call by value, but since it has primitives for referencing and dereferencing, you can produce side effects through the call by value mechanism, right. So, there is another variation of the call by value parameter mechanism, and that is called the call by value result, right. And that is very simple, you just proceed exactly as in call by value, okay. The only extra constraint is that your actual parameter should also have an L value, right. So, if your actual parameter is some, let us say some arithmetic expression 2 plus 3 is what comes to mind always, then obviously call by value result is, I mean it is not going to, I mean it does not satisfy this constraint, but if the actual parameter is something which also has an L value, then what I can do is proceed exactly as in call by value, and after the, and just as there is a copying in phase in a call by value mechanism, you first find the R value of the expression and you find the R value of the expression and then you actually do this assignment to the formal parameter, right. So, this is the copying in phase. So, just like you have a copying in phase, after executing the procedure you have a copy out phase, okay. So, where you will actually copy back values from the formals to the actuals, right. So, a call by value result is just call by value plus this extra step which is firstly with this constraint that the actual parameter should also be a location, and after executing, I mean it is because you have to copy back values from the formal to the actual, and you can't do that in a memory based system without the actual parameter actually also denoting a location, also having an L value. So, then this copying back is done and essentially you have created a side effect, but in a clean fashion, I mean in the sense that there is no great interference between the globals and the body of the procedure. I mean the procedure still remains as an abstract, but you are copying back the values at the end of the execution of the procedure. All intermediate values of the that the formals take within the procedure will not be reflected in the actual parameter. Okay. So that's a call by the call by value result is as I said, it is not actually used in any programming language, except that Ada has 3 kinds of parameter mechanisms. Okay. So, a typical Ada procedure could have what are known as in parameters, okay, which are quite faithfully reproduced by the call by value mechanism. Okay. Then there are in out parameters, which means there is a copying in phase of these parameters, and at the execution of the end of the execution of the procedure there is a copying out phase also. Okay. And then there are also plain out parameters. Okay. So, you can think of this plain out parameters as a form of what might be called just call by result. I mean there is no copying in phase for these out parameters, they stand let us say essentially uninitialized when the procedure begins execution, but at the end of the execution there is a copy out of values, and you have essentially I mean, so you do not have a copying in phase, but you have a copy out phase. So, you can call that a call by result mechanism if you like. But the whole point about the Ada language is it does not specify how these things have to be implemented. It is just a generally accepted conjecture that this is what the designers meant. Okay. So, that is why there is that question mark there. Now, what actually most languages from Fortran always tried to implement was always provided was what is known as a call by reference mechanism, which is the variable parameters in Pascal, right. So, what happens is you actually assign to the formal the L value of the actual parameter, and then you execute the procedure with this proviso. So, that whenever the R value of the formal parameter is required, you take the R value of the corresponding actual parameter, and whenever you want to change the value of the formal parameter, you actually change the value of the corresponding actual parameter. So, the formal parameter or whatever is regarded whatever is the space reserved for the formal parameter in the activations record is just an address to the actual parameter, and within the procedure whenever it is a formal parameter that is being assigned or being used, whose value is being used, actually the value is not taken from that formal parameter, but you go down that pointer to the location where the actual parameter is, and either use the value inside that or modify that. Okay. And this is so the call by reference mechanism was what was used in Fortran a long time ago. It is used in Pascal through the var declaration. It is there in Algol 60. It is there in so many languages, and it is there in C by virtue of the fact that C allows referencing and dereferencing, but it is not explicitly provided by the C language. The only explicitly provided mechanism is the call by value mechanism, right. So let us look at a few examples of these things. So, supposing you have I will use a Pascal like syntax throughout. So, let us consider just this trivial example taken from an elementary programming course on Pascal. So, I have this procedure swap with two with two formal parameters x and y, declare integer. I have an integer, an intermediate variable t also declared to be an integer, and then I have the standard swap procedure, right. And now I call this procedure with two actual parameters a and b. Okay. And now by default, if it's if this is a Pascal program, then this x and y are implemented as value parameters. So what it means is that first there is a copying in phase. So the values of a and b, the r values of a and b are stored in the locations corresponding, the locations for x and y, and then the values of x and y are actually swapped. Okay. And when you get out, the values of a and b are still the same old values, right. So that is okay. So there are no changes to the values of a and b. So the standard thing to do this, so what you could do is you could implement it by a call by value result mechanism. Supposing we extended this, the Pascal parameter passing mechanisms to value result, then what it means is that I would assume that the body of the swap procedure is the same, except that I have made this change. I have declared x and y to be value result. Then what happens is that in the copying in phase, x and y are assigned the values of a and b, then the values of x and y are swapped in the procedure body, and then there is a copy out phase where the actual parameters are assigned the values of the formals. So that is what I mean by a clean interface. I mean, you can look upon this, I mean, if you look at the procedure as a single entry, single exit black box, okay, with the parameters forming the interface, then it is a clean interface in the sense that there is a copying in which corresponds. So the transmission of the parameters is through the interface for through the copying in portion, and then there is an output through the copy out phase. Okay, and the rest of the program, while this procedure is executing, essentially if globals are not referenced, globals are not modified, and so on and so forth, then what it means is that this procedure stands alone and can be used by others as a distinct complete functional unit in itself, as an abstraction in the true sense of the word, right. Okay. On the other hand, of course, what we normally do, since the value result mechanism is not available in Pascal, what you do is you usually implement this swap by reference, right. So you actually define these two formal parameters to be var parameters or reference parameters, and then the mechanism goes something as follows. So yeah, so x is assigned the value of a pointer to a, which means the address of a, y is assigned the address of b. Okay. So this type information here is only refers to the type of the actual parameter and not to the type of the formal really. Okay. All that you are saying is that it should, x can be a pointer to an integer actual parameter, right. And then after that what happens is that the body of the procedure executes actually in this fashion. You dereference x and take that value and put it in t, and the act of dereferencing x means going to the variable a, taking its value and assigning it to t, then dereference x, that means go to a, and to it assign the value of the dereferenced value contained in y. So dereference y, which means go to the location b and copy that value into the location pointed to by x, and then of course copy the value of t into the location pointed to by y. Okay. So the side effects are immediate. right. So, the side effects are immediate, unlike let us say the call by value result mechanism. So, essentially if you look at these three mechanisms, then as long as you have referencing dereferencing primitives available, what you could do is you could all effects of call by reference can be captured by call by value, and which is what C does, and which is what many people do in Pascal because of Pascal's peculiar constraints on what functions can return. Okay, either you define it as a procedure or you define it as a function, return a pointer parameter to some structure, right. I mean that, and then you will get the same result. Yeah. So essentially all the effects of call by reference may be captured by call by value, but provided you have these referencing and dereferencing primitives already in the language. Otherwise, of course, you can't. Right. Now, in the absence of referencing and dereferencing primitives, what we have is of course that the call by value can produce no side effects except explicit assignments to globals and so on and so forth. And but all call by reference side effects can actually be captured by call by value result, and the only difference is that this effects are not immediate in a call by value result mechanism. The effects are delayed, I mean they are delayed till you actually are exiting the procedure, right. But however, there is a catch to this, which actually most books do not point out, okay, and the catch is here. And this you can capture all effects of the call by reference, all side effects of call by reference by call by value result, only provided all the actual parameters in your procedure call are distinct. If you have an aliasing problem, okay, you have actually used, okay, let's look at this. So, if you have an aliasing problem, then there is no guarantee that the effects of call by reference will be captured by call by value result and vice versa. There is absolutely no guarantee that the effects of call by value result will be captured by call by reference. Okay, and so here is a simple example which actually does this. The important thing here, I mean here, so look at this. So, this is this procedure presumably takes values x and y, which are let us say integers, and then it gives the quotient and remainder of the input values x and y and stores them also in x and y, because assuming somehow that you do not require the original x and y and you want only the quotient and remainder, then what this procedure does is it somehow does this. But then there is nothing which prevents me from calling this procedure with x and y being the same L value, right. Then actually what will happen is this order of evaluation and the last statement which modified A is what is going to take effect, okay. And since the effects are immediate, well, in order to buffer the effects being immediate, I have used this intermediate variable t and used it throughout, otherwise I might have used y here. But so essentially what it means is the result of this procedure call is going to be that A will have the quotient, which means 1 if A is not 0, okay, at the end of this procedure, or it will not have that, maybe it will have a is equal to x mod t, that is 0. Oh no, yeah, it will have, right, it will have 1. I have luckily programmed it right, okay. Now under the value result implementation, what happens is that you here at the end of this procedure, x actually contains the quotient of the original a and a, which is 1, y actually contains the value 0, but depending on in what order you do the copy out phase, it will be reflected in this actual parameter. So, which means supposing you assume that all sensible compilers and runtime systems do the copy out phase in the order, because parameter orders are important always. So, if they do it in this order, then essentially what it means is that a will have the value of y, which means it will have 0. So, in this case you will have a equals 0, and in this case you will have a equals 1, right, which is an excellent reason for not doing this kind of programming.
So there will be another problem. Suppose inside the procedure we use the actual parameter also, then also
Once you use the actual parameter inside the procedure, then there is just confusion confounded. Okay, so let us not get into those complications. This is just to point out a difference between these two in effects, which is usually not pointed out in most books on programming languages. Most books actually claim that the effects of call by value result can be captured, the effects of call by reference can be captured by call by value result, and it is not entirely true. Yeah. Okay. However, so but call by value result is a very clean mechanism in the sense that it does not give you unnecessary headaches. However, the point is, the problem really is what happens when you have to pass really large structures. I mean, whereas call by reference actually can make things quite complicated, especially with array referencing, array index computations, array index modifications inside the procedure, and so on and so forth. It can make things quite complicated, and reasoning about in a call by reference environment can be quite tricky. It means debugging also could be tricky, right. So, however, call by reference is actually the most economical way of passing large structures, huge arrays, a bitmap of yourself for example to be transformed somehow into, maybe to make you look more handsome or something. But what I mean is, you want, if you are going to pass large structures, then you would also like to be economical about your usage of the store. So, what you don't want is to create an output which is another large structure. So, very often you just want to create the side effects on that structure itself and have those side effects available to you at the end of the execution of the procedure, right. So, when you if you have really large structures like 1,000,000 bits by 1,000,000 bits passed as a parameter, then the copy in phase and the copy out phase are going to be extremely expensive. So, even though you might get your results through a call by you might get correct results through a call by value result mechanism, it is actually faster and more space efficient to use a call by reference mechanism to produce the required side effects, right. So, that is what happens with call by reference. So, this is one of the reasons why call by reference is most popular, because even for large structures all you require is a single address, that is it, as a parameter. So, your parameter will just contain a single address to the start of the structure, and that is it. So, whether it is large list structures or large array structures or record structures, it does not matter. One address is all that you require, a single pointer. Okay. So, then let us look at the call by name mechanism. So, in a call by name mechanism, essentially what you are saying is that a formal parameter is just a name for the piece of text which comprises the actual which comprises the actual parameter, right. So, what you do is you go back to the lambda calculus and try to model the behavior of the beta reduction there exactly in your programming language. So, how would you do that? So, that means before executing the procedure, I replace all occurrences of the formal parameter in the procedure body by the text which is the actual parameter. Okay. So, essentially the effect of a call by name is to produce a macro expansion. Okay. You produce a macro expansion, except that just as in the case of a beta reduction, you have to be careful. There should be no free variable capture. Okay. So, essentially if you look at the in the when of course, in a compiled language this may not be such a serious problem, because since every variable will have would have an address determined by the base of its activation record and the relative address with respect to the base of its activation record, this problem may not be so serious at runtime for a compiled language. But looked at as a form of beta reduction being modeled in an imperative programming language, what it means is that, so you have to replace all occurrences and of the formal in the procedure body by the text of the actual, and to avoid free variable capture, what you have to do is you have to rename all local variables in the procedure by an alpha conversion mechanism, right. But in a compiled language, that part of it could be automatically done, but what happens is that in the case of a so essentially the resulting procedure, when you replace all these formals by the text of the actual expression, the resulting procedure should be executed as an unnamed block in the calling environment. That means, the procedure call is just an abbreviation for taking the entire body of the procedure after replacing all the occurrences of the formal parameter by the text of the actual parameter. So, the execution of the a procedure call just has the meaning that it is an unnamed block. A procedure call is just an abbreviation, a parameterized abbreviation for an unnamed block that has to be executed at that point, with a substitution of the parameters by the text of the actual parameter, and of course ensuring that there are no free variable captures. So, this aspect is what is really a beta reduction in the lambda calculus, and that is what is obtained by a call by name mechanism. And since all the execution is in the calling environment, in the environment of the procedure call, all side effects are immediate. Okay, and you can actually pass large structures, because you will just be giving the large structure a name and passing it, that is it. So, depending on how your runtime environment deals with large structures, I mean, for example, arrays, regardless of what language you are looking at, arrays are still just a pointer. Okay. So, your side effects will be immediate, and you do not have this extra overhead of what happens in, I mean, you do not have this copying in, copying out, all that. The effects on large structures are also captured immediately. Array dereferencing or array indexing and so on. The only problem with this is that reasoning about the program from its text can be quite a problem, right. And but of course, so that is so this is so, and there is of course another effect which call by name, and of course there is no guarantee that call by name is equivalent to call by reference. or any other mechanism for that matter. All these mechanisms are different, because what happens is that it is different from call by value, because in call by value the parameter is evaluated once to a value, and that value is used throughout all references of the formal within the procedure. In the call by name, because of a textual replacement, that actual parameter is evaluated every time that formal is referenced inside the procedure. So, what it means is an expression like a plus b passed as an actual parameter to the procedure, so that a plus b can mean different things in for different references of x in that procedure, because you may have modified a between two successive references to the formal parameter. Okay. So, in general for imperative languages this is not the same as using a call by value mechanism. It means repeatedly evaluating that expression every time that formal is encountered. You execute the text corresponding to the expression and essentially re-evaluate that expression, but you re-evaluate that expression in the calling environment. Further, this call by name mechanism can produce different effects depending upon whether your language is a statically scoped language or a dynamically scoped language, because then your references, because your textual the text of your parameter really is consists of non-local references. So, then depending upon where it is being called, those non-local references have different bindings. Okay. If you call it, if you have it in the environment of the procedure call, if you have it in the environment of the call, then in a statically scoped language the parameter is referred to the innermost enclosing innermost textually enclosing block, whereas in a dynamically scoped language they refer to the binding in the innermost calling block. So, even call by name, depending upon whether you are talking about a statically scoped language or a dynamically scoped language, can produce different effects, right. Okay. Lastly, there is just one more thing, and that is that many languages like Pascal have procedures as parameters. Yeah, and here there is no question of whether it is call by name or call by value or anything of the sort. So, supposing you have this set of procedures, this main body, where of course the main body has this call to this procedure P, which is blue. The main body has two procedures Q and P. Q is black and P is blue. The blue procedure P has a function inside it. The black procedure Q is a procedure which calls a function as R as a parameter, okay, and this R is also just a formal name, right. And then let us say there is a call to this Ri here, the Ri is used here, and now what happens is, if you look at this call, there is a call to P, and then within P there is a call to Q with the function f passed as a parameter. So, that means this formal parameter R now refers to this function deeply nested inside this P, okay. So, the question is, what is the environment of non-local references inside the function? Okay. The point is that in a Pascal, in a statically scoped language, this x should refer to this pink x here in the main body. Any reference to I here should be this blue I here. Q itself has an x and an I. This I here, this black I here refers to this black I here, but when you call this function with this I here, then you are actually using this blue I within Q. So, you have to somehow create the static environment suitable for f in order for f to be executed at this point. and that is very simple. What you do is at the point of this call for a function or a procedure parameter, you also send along with the parameters and so on, you send the static chain pointer address for the current base. So that all references to I and x within this function would refer to the non-local references in keeping with the statically scoped structure of the language. Okay, I mean this is a separate, but this is a very weak parameter passing mechanism and actually creates more confusion than it solves, but it is an excellent way of, for example, programming higher order functions like map, at least first level higher order functions like map and whatever list based functions which have to be applied over the entire list. Or for example, solving you can have a Newton-Raphson method in which the actual function is called as a through a parameter. The actual function could be a trigonometric function or a hyperbolic function or could be a polynomial or mixtures of these things. You call that as a parameter, and that's the reason it was introduced in Pascal, for doing such kinds of computations independent of actually what the value of the function is. So, you can call Newton-Raphson with this function f and maybe find a fixed point solution. But what it means is, along with the function name, and the type checking becomes problematic. Pascal is the rules of Pascal are inadequate to adequately type check this mechanism, because Pascal tries to save on your effort by saying that you do not need to declare all the variables, all the parameters. But then if you do not declare all the parameters, how are you going to type check? Pascal thinks it is being more flexible by not allowing parameters, so that now you can actually call it at different places with a unary function or a binary function or a ternary function, but then you can't type check those things, and it violates the static type checking rules of Pascal, that at compile time everything should be type checkable. It violates that basic requirement. So, anyway, it is not a very popular thing, but it is a way of programming higher order functions in an imperative language.